All right, so let's try another conversation with Era here in a second. First of all, I want to see how I need to wake her up, whether it's by pushing the Grok icon or by the control wheel or on the steering, control roll wheel on the steering. Hey, Era. So the voice, just pure voice command didn't seem to work. Hey, Grok. I'd say that's a no. All right, we'll press the control wheel steering on the right side. Hey, Grok. It says comment not understood. All right, so let's go to the icon down at the bottom of the screen. Good morning, Ara.
Morning. What's up?
Want to talk physics?
Sweet. Let's dive into physics. Want to geek out on quantum mechanics, relativity, or maybe something like black holes? What's sparking your interest?
Fluid dynamics.
Nice choice. Fluid dynamics is all about how liquids and gases move. Think swirling coffee or jet streams. Want to focus on something specific, like Bernoulli's principle, turbulence, or maybe real-world stuff like aerodynamics? What's the vibe?
Water movement.
All right, water movement's a cool slice of fluid dynamics. Water flow gets wild. Think rivers carving valleys, or waves crashing. Want to dig into how water behaves in pipes, open channels, or maybe ocean currents? Or should we talk real world, like how dams work, or why your garden hose sprays weird? Pick a direction.
Let's go real world. How much does a gallon of water weigh?
A gallon of water weighs about 8.33 pounds at room temperature. If you're thinking practical stuff, like carrying a jug, it's roughly that, but it can shift a tiny bit with temperature or if it's salty like ocean water. Want me to dig into how that weight plays into something specific, like water flow or transport?
In just a minute. So then how many gallons of water are in a cubic foot of water?
A cubic foot of water holds about 7.48 gallons. That's handy for stuff like figuring out tank sizes or pool volumes. Ready to circle back to that real-world water flow topic, or you got another question brewing?
So then what would be the weight of a cubic foot of water?
A cubic foot of water weighs about 62.4 pounds at room temperature. That's based on water's density and the 7.48 gallons per cubic foot we talked about earlier. Want to tie this into a real-world flow scenario, like how much force a stream of water packs?
Yes.
Awesome. Let's connect the dots. A cubic foot of water at 62.4 pounds can pack a punch when it's moving. Think of a fire hose. Water's weight plus velocity creates serious force, which is why it can knock people over. Want to explore how water's weight impacts flow in something specific, like rivers, pipes, or maybe a dam spillway? Give me a nudge on what's catching your interest.
A river.
Rivers are a great example of water's weight in action. That 62.4 pounds per cubic foot means a fast-moving river, like one with a steep drop, can erode banks or carry debris with serious force. Think tons of water rushing per second. Want to get into specifics, like how a river's flow rate affects erosion, or maybe how engineers manage flooding? What's the river vibe you're thinking of?
How do you determine the increase in water content of a riverbed?
To figure out how much more water a riverbed holds, you'd look at changes in flow rate, which is tied to water volume passing through a section over time. Scientists measure this with stream gauges that track water height and velocity, then calculate discharge, volume like cubic feet per second, using the riverbed's cross-sectional area. More rain or snowmelt upstream boosts the water content, while drought drops it. Comparing gauge data over time shows the increase. Want me to dive into a specific method, like how to estimate it yourself, or what tools hydrologists use?
Talk about how to estimate it myself.
Estimating a riverbed's water content increase yourself is doable with some basic steps. First, pick a section of the river and measure its width and depth to get the cross-sectional area, say in square feet. Next, estimate water velocity by timing how fast a floating object, like a stick, travels a set distance, converting to feet per second. Multiply area by velocity to get discharge, cubic feet per second. Do this during different conditions, like after rain, and compare to see the increase in flow. For rough numbers, you can eyeball depth changes or use a yardstick. Want specifics on tools or how to account for tricky stuff like uneven riverbeds?
Uneven riverbeds.
Uneven riverbeds can mess with your estimates that you can tackle it. Instead of assuming a uniform depth, measure depth at multiple points across the river, say every few feet, and average them to get a better cross-sectional area. Use a stick or rod to probe the bed's depth, noting dips or rocks. For velocity, take several float tests across the width, since water flows faster in deeper, smoother spots. Multiply the average area by the average velocity for a more accurate discharge, cubic feet per second. Comparing these over time shows water content changes. Want tips on simplifying this or dealing with super rough beds?
No. How much force, water force, would it take to move a vehicle?
The force of water needed to move a vehicle depends on the vehicle's weight, shape, and the water's speed and volume. A typical car weighs about 3,500 pounds, so water needs enough momentum, mass times velocity, to overcome that and the friction holding it in place. For example, fast-moving floodwater at 6 feet per second with a depth of just 2 feet can exert around 1,000 pounds of force per square yard, enough to push a car sideways or lift it slightly. A rough formula is force equals water density, 62.4 pounds per cubic foot, times velocity squared, times the vehicle's exposed area. Want to narrow down to a specific vehicle type or water scenario, like a river flood or flash flood?
Not yet. So I enjoyed that. Thank you very much for your help, Era.
Glad you had fun geeking out on water and physics. Anytime you want to dive back in, I'm here. What's next on your mind?
That's it for this morning. Thank you.
All right, catch you later. Thanks for the physics chat.